Swayam Prabha. Digital India. Educated India.
What exactly is the cloud? Okay, so the best example that I give, even though the uh, slide actually talks more about a lot of these iCloud and Google Drive, etc. options, the one of simplest applications of Google Cloud or any cloud for that matter would be say Gmail or Yahoo Mail or any of these mail services, right? So if you compare say a Yahoo Mail with say industrial email, so when we are accessing our work emails, okay, uh, not now anymore. I think with most of the email providers also having gone on cloud, but maybe 5-10 years ago, if you were talking about enterprise email, typically you would have say a Microsoft Exchange server or any of these popular say IBM Notes mail server, etc. So these were some of the popular mail servers which were there, and you had to actually have your own data center. You had to have your own farm of servers where you would bring these DVDs of Microsoft Exchange, and you would install the Exchange server. So you are right from the data center to the machine software. You had to actually purchase the license from Microsoft or IBM, etc., and set up the entire email. Okay, so that is the typical example of what we used to call as on-prem on-premise software. Versus if you take a look at any of Google Mail, Yahoo Mail, etc., these were something that we as users never used to bother about how to install the same, how to configure the same, etc. All we had to go was go to a browser, open the URL, and sign in, and we are good to go, right? So that is a typical example of cloud. So essentially, what is cloud? The idea is that on a slightly lighter note, again, this is another thing which I liked about this particular PDF. They've also put in some few jokes around. So essentially, cloud is nothing but, as this joke says, it's someone else's computer accessible over the internet. Okay, so that's the basic introduction that I can give about, Google Cloud, or for that matter, any cloud. Okay, so the main idea is your data, your applications, whatever you are hosting on the cloud, they are no longer on your own premise, okay, or on your own data center or your own machine for that matter. Okay, it's on the internet, and theoretically, at least, it's available, accessible to anybody from the internet. Okay, so that's the definition of cloud. Now, when we go a little step further, so this is a typical example of a cloud data center. It'll be like a huge, say, factory or a wholesaler kind of a big building, and you'll have rows and rows of these server farms installed over there. So that's what a typical data center looks like. But the moment you talk about cloud, so say if we take an example of TCS itself, right? So TCS, we have our own bunch of applications which we use for payroll of our employees, for tracking work allocations of our employees, etc. And therefore we have our own data center as well. So TCS has a few data centers spread across the world, but at the same time, we also utilize certain cloud products like Google Cloud, Azure, AWS, etc. And that is where the applications which are hosted on those clouds, they are actually no longer in our data center. They are not in the TCS data center. So they are either in the Google data center or the AWS data center, etc. So that's your typical example of how a cloud connection looks like. Okay. So I hope I'm making sense so far. Um, Now, coming specifically to Google Cloud Platform. So, and again, this is also, to quite an extent similar with any of these providers. So, what does a cloud platform typically provide? So, what does a computer typically have, right? So, if you take a look at the computer, except for the input and output devices like mouse and keyboard and your monitor, etc. What is the core of any computer? It's basically your computing or the CPU. Then you have some sort of a hard disk, which is your storage. Okay. And then, you have various applications installed on the computer, right? So that is what is similar to the services that are offered by any cloud provider for that. So you will have compute services where you can actually have these virtual machines which you can spawn up. So instead of having to buy a server, from say a Lenovo or a Dell or whatever, all you have to do is the server purchases and everything. Google or AWS has already done for you. The moment you need, a certain say. CPU with say 32 GB RAM and 500 GB hard disk, etc. All you have to do is just fire up one virtual machine, and your billing also starts at the same time. You can start using it as well, right? So that's what is a computing service. Similarly, you have storage services. So just like you would suppose you're running out of space on your local hard disk, you would have typically purchased, say a USB extension hard disk or something of the sort. So in on similar lines, you have these various storage options which are there, which are provided by all these players, and your computing. Now, the moment you're talking about storage, the next typical application of these storage devices would be, apart from storing files, you would also like to store data. Okay, so databases come into the picture, big data comes into the picture where we are talking about data warehouses, etc. Moment you have data warehouses, you will typically have some sort of analytical applications which will be there. Then you have cloud security as well. You have a lot of developer tools which are available to you, which you can use to build applications on the cloud, etc. And then, of course, the flavor of the last few years, ever since ChatGPT broke ground, machine learning and AI related services, right? So these are a typical representation of the kind of services which are available on this Google Cloud platform. Okay, so the idea is that any of these services, if you want, instead of the old way of purchasing hardware and hosting it in your own on-premise data center, etc. All you can do is in a matter of seconds or minutes, you can fire up any of these services and start using them. Okay, so that is the core concept of any cloud platform. Okay. Now, taking a look at some of the, again, this is again in a way talking about the same thing that we were talking about earlier, that when we are having our own computer, etc., how do you take care of things like backups, sharing information, etc. So there are various options which are, so for example, Google Drive, iCloud, Dropbox, etc. There were, of course, physical options also like the USB zip drive, etc. But here we are talking more in terms of the application, scenarios. So these are some of the features that most of these cloud providers, again, use. Now, if we take a look at some of the common enterprise use cases, okay, where we as in TCS, so quick background on myself. I've been with TCS all my career of 25 years. So I was very much, born into the on-prem era. Unlike most of the current generation, all of you, who are more born in the AI era or the cloud era. So I have actually seen these, kind of progression where earlier we used to have, users, applications, servers, etc. And as this slide is trying to explain, so suppose you are, say a startup, okay, in the year 2016, you are a startup and you had a few users who are using your application, etc. And you purchased, some servers and you wanted to, these servers were sufficient for your usage. But the moment your startup, suppose, becomes a hit, and you start seeing more and more users coming on board onto your application, whatever is your service that you're providing, you will have to exponentially, according to the requirement, keep increasing these racks of machines. And pretty soon, you will run out of physical space in your, whatever office premise, whatever you might have taken. Then you might have to take a larger, premise on rent or, purchase, etc., whatever. So that's a typical, scenario of enterprise users as well. How, the demand was increasing so much. And again, since I've been part of that era when we didn't really have this cloud option, I very clearly remember we were in a project, where we were starting this Siebel CRM implementation. And I still remember it took the client. So we were implementing it for one of our manufacturing clients in the US. And the client had to spend almost a month or a little over a month to just provision certain development servers. Okay. So that was the time that was required for actually purchasing servers, from the market and getting them into the client's data center and having the infra team set up the operating system on those servers, then setting up the application on that server. It was at least a month, month and a half just to give the development specification kind of machines in. So for that month, month and a half, I still remember we had started setting up the team, and most of us were busy, just undergoing training on Siebel CRM and stuff like that. Okay. So now that the development servers came within a month or two, I still clearly remember that the production grade servers, which were actually going to host our application when it was going to go live, that took a nice, 5 to 6 months for those machines themselves to come up. Okay. So that's the, kind of time frame, because all these things, if you look from a company point of view, right, you cannot just go to the shop and buy a server and install it and you're ready, right? You have to go through a lot of formal processes. You have to first, get the budget approved. You have to get the various specifications clearly called out. Suppose today you think that, say, 32 GB RAM is sufficient and you put in that request, and when 3 months later, when the request actually gets approved by all the approvers, and you actually send out the quotation to the vendors and you get back the responses on those quotations and you finalize a particular vendor, easily 2 to 3 months will go, and for all you know, you might think that, okay, 32 GB is too low for me. Okay, so I might have to go with, say, a 64 GB RAM or something. So these kind of changes, main that we are trying to say out here from this slide is that any kind of expansion in on-prem, infrastructure used to take a lot of time, space, and also a lot of initial, expense that you had to put in just to make sure that your machines are in. Okay. And then the moment, more and more, and yeah, so the next scenario that they're depicting is, suppose for some reason, okay, suppose you have some downturn in your business cycle, or say maybe not 2018, but suppose it is 2020, or when the COVID struck us. Okay, so suddenly the user demand goes down. Okay, and from 20,000 it comes down to 7,000 users. What do you do with these extra machines that you purchased, right? You don't really need them anymore. So this is the concept what we also call as business elasticity or agility. Okay, where when you're purchasing machines upfront, you cannot really purchase them quickly enough, nor can you get rid of them quickly enough. Okay, so sometimes, a lot of the businesses that we see, especially things like, say, retail, consumer goods, etc., they are very cyclic in nature. Okay, you will have a peak season kind of a thing. Say, for example, recently we had Diwali, Dasera deals, etc. So a lot of the retailers will have a huge amount of demand, and then again, there'll be periods when there'll not be much activity, and every year you will see some sort of a seasonal pattern. So what do you do in such cases, right? When during peak demand you need more hardware, more infrastructure. You cannot just buy it immediately, nor can you get rid of it the moment you're done. But the moment you're talking about something like a cloud, you can very easily deploy all these functionalities. The moment you see a rise in demand, there are few auto scaling, etc., where you can actually increase the number of CPUs that are there with you. The moment the demand goes down, automatically the extra CPUs will shut down, etc. So all these kind of features are easy to use, on the cloud, much more convenient than it is on the on-prem systems. Okay, so that's the purport of this. So this is what the next slide is showing. So automatic, scaling of, your servers increase, your users increase, you can increase the servers. The users go down, you can bring them down, etc. So this is one of the features of cloud in general, and of course provided by Google Cloud as well. So you have fault tolerance, high availability, scalability, and elasticity. So these were the four topics that we covered so far. Fault tolerant was all about, and we'll take a look at each of them in detail as well. But the idea is that because Google, Azure, all these providers, they have data centers in multiple locations across the world and even within countries. Okay, so within India, typically you'll have data centers spread across Mumbai, Nagpur, Chennai, Delhi, Lucknow, Kolkata, etc. So even within a country, you have multiple regions and availability zones, etc. Are the terminologies that are used. So any one particular data center goes down for whatever XYZ reason, you can always go back to the fault tolerant server which is there. Similar concept with high availability. So make sure that any downtime are minimized. You don't really need large outages for maintenance activities, etc. You can have a highly available backup with you. Scalability is all about you're talking about the ability to ramp up easily. So or even there are features like suppose today you have a startup and you have your products which you're selling within India. Tomorrow you want to sell them out of Europe as well. So what do you do? In a normal scenario, you would have to send somebody to any of the European countries, finalize some office space, purchase some hardware to host your website over there, so that it's accessible quickly, etc. And that kind of a concept you'll have to, obviously it will take a long time, right? But with global cloud providers like Google, all you have to do is specify that, okay, tomorrow I want to set up my clone of or replica of my website in, say, France or Spain or Germany or US or anywhere. And within minutes, again, there are services such as CloudFront from AWS, etc., which can immediately replicate your website and make sure that users who are going to your website, same domain name, if they are coming from US, they access the server from the server which is there in the US. If they're accessing from Europe, the traffic will be routed to the servers which are in Europe, etc. So that way, again, highly scalable, highly very easy to provision all of these things on the cloud. And then we took a look at the elasticity as well. Depending on user demand, we can increase or decrease the the consumption of your various resources. Okay, so these are the four concepts we have covered so far. Now, taking a look at something known as virtual private cloud, and how do you actually make sure that your users are reaching the correct place. So the compute engine, okay, so these are some of the typical services which are used. Okay, you have compute where you have various kinds of hardwares and virtual machines which you can use. You have different types of storages which are available. So object storage, data storage, file storage, etc. You have various big data services as well. When we are talking about unstructured data, social media, posts, blogs, videos, reels, all this kind of data, and then even machine learning related services. If I take a look at any of the, say the compute engine, these are some of the, typical uh, terminologies. So in a example of on-prem, we used to have a computer which was a CPU, RAM, and hard disk. And now you have a compute engine, okay? A Google terminology for what is generally known in the industry as virtual machines, okay? So when you fire up a Google compute engine, it has and you can specify what kind of a server do you want. Okay, so what CPU, RAM, storage, etc. do you want on the server? Then what kind of network is that server located in? How do you want to protect it? Does it have to be freely available on the internet, say for some public website, etc., or should it be entirely accessible only from within your company networks, etc.? So all the firewall and security you can take care of. You can even specify which operating system do you want. Do you want it to have Windows, which version, Linux, which version, etc. So all those details you can specify when you are purchasing a compute engine product from Google. Okay, so that's your typical virtual machine offering from Google, which is called as compute engine. Okay. Now, typically, some applications, so Spotify, etc., is a typical, I'm sure, quite a super hit service. So that is something that's hosted on Google Cloud. Okay, so that's your compute engine. Now, the moment you have a compute engine, the next is where do you host that compute? Okay, so that's where a concept of virtual private cloud comes into the picture, where your compute engine, how accessible is it? That's what you're trying to define. So virtual private cloud is essentially, think of it as a cloud which is accessible only to your own machines or your authorized network. Okay, so on the one hand, you have the public internet where anybody and everybody can go to any website, but at the same time, the moment you want to have your own home network, so typically you have a printer, machine, etc., your laptop, desktop, mobiles, etc. So the concept of a home router, okay, is essentially in a way mimicking your virtual private cloud. So the home router is while on the one end it is connected to the internet, on the other end you can also specify that, okay, I want certain devices to be accessible only internally. I do not want anybody on the internet to be able to access my laptop or say my mobile, etc. But from my laptop, I should be able to access my mobile or vice versa. Or from my laptop, I should be able to access my printer, but nobody else from the internet should be able to. Okay. So typical scenario at back at our houses. So same concept applies to the virtual private cloud. It's a home network of your particular company. Okay. So whenever you have the option to have a internet connection also, and then you have the option of having internal or intranet connections to this compute engine. Okay, so that is what is a VPC in short. Okay, I hope I'm not going too fast. Let me know if you're getting any such feedback. Okay. But so far we have done, exploring certain general options or features of cloud in general. And then we have taken a look at the compute service as well as the, virtual private networking kind of service, which is there in Google Cloud. Now we'll step into various database options which are there. Okay. So again, so when you're talking about databases, okay. So typically, we used to have long back, we used to have things like structured data where you used to have tables and columns. Okay. So tables with rows and columns. So that is your typical example of a database. But then at the same time, why do we need to take a look at database as a separate, entity apart from compute? Because finally, what is database? Database is nothing but compute and storage, right? But compute and storage, there are different types of databases. Okay, So whenever you have these different types of databases, you have to take a look at various usage of these databases. Okay, so whether they are going to use structured data, if they're going to have encrypted data like say login information or cards information, etc. Okay, whether they're going to have dynamic data such as say inventory which is getting updated every second, every moment there is an order, inventory has to be updated every day in the morning when you are receiving goods from your suppliers, you have to update the inventory, etc. So what kind of access patterns are you looking at? All that actually makes a big difference to the use case that you need for your particular database. Okay, so with the power of various cloud, we'll also take a look at data centers and how they are useful in the various scenarios. Okay, we took a look at this one. So I went back a little bit. Give me a minute here. So okay, we are going back to the scalable fault tolerant. We talked about this. I'll skip these concepts. But coming now to the concept of storage. Okay, so storage is also something which is very important in the use of how do you want to store various different things. Okay, so apart from databases where we are talking about more structured data, your storage, you can have these days, apart from your tables and columns, you have a lot of media which is getting generated. Okay, whether it's documents, whether it's movies, reels, audio files, even this YouTube recording for that matter. When we have gone live on YouTube, somewhere it has to be. This is also known as streaming data. So the streaming data will be there right now. It has to be streamed live as I'm speaking. All of you are able to, hear me on your particular machines, etc. So that is known as streaming data. And at the same time, the moment the session is over, the recording for it will end up generating a video file. Okay, so that's one of the typical use cases of cloud storage. So you have different kinds of data which needs to be stored on the cloud. Okay, so there are different options which are available. Another typical term which we use for cloud storage is we call this as a bucket. Okay, so you can have a bucket, and in that bucket you can keep all sorts of things. Okay, so similarly there is this concept of a cloud storage bucket where you can have multiple kinds of data which can be stored. You can have songs, movies, databases, documents, everything in the same storage bucket. Okay, and typically these are extremely scalable to this extent that literally you have unlimited storage. You just have to take a plan that, okay, every few GBs, this is the charge that I'm going to be billed, and you practically have unlimited storage. Okay, that's how these large vendors like Google and Azure and Amazon are operating. Literally limitless amount of storage is available. Okay, so that is your so far the concepts of storage, databases, compute, and virtual private cloud. Okay. So Gurudayal, I can see a question about risk, of data privacy, data security, etc. So that's typically a very valid question. This was probably a cause of concern, Gurudayal, maybe 10 plus years ago when cloud was still a new offering, and people were a little skeptical about because finally, see, another concept which I wanted to also share with all of you was this is a cloud concept called multi-tenancy. Okay, so how do you think a company like Google is able to provide all these limitless storage, almost limitless compute capacity, etc. Today I want to fire up 100 virtual machines on Google Cloud. I can do that. Okay, so how do you think it is able to provide this? So the concept behind the cloud is something known as multi-tenancy. You can again look it up. I don't think I have any slides on this in this particular thing, but the idea is that the same hardware is essentially shared between various tenants or various clients. Okay, I'm just giving a hypothetical example. Please don't quote me on this. But it's very much possible that the same machine might actually host, applications from say both, say an Amazon or a Flipkart, right? Cutthroat vendors. You can have a same server which can have, say, applications which are shared by the most, say, Pepsi versus Coke. Okay, so these corporations, which are tooth and nail fighting with each other, competing with each other, etc. It's very much possible in today's day and age with the software plus hardware infra that is available to separate out these things. So even if you have the same hardware actually shared between two different companies, there is not much about not much concerns left now with respect to privacy, data security. Having said that, there was also, I think I saw a question from someone that can you explain the concept of virtual private cloud again? So the idea is that I'm sure you guys must have heard about this term of public cloud versus private cloud versus hybrid cloud. Okay, so public cloud is nothing but your compute and storage and everything available directly on the internet. Okay, so say something like a Spotify, right? So when you are taking a look at the Spotify app, okay, which we talked about, the Spotify app is, the app contents and the website and everything is available freely across the internet. But having said that, I'm pretty sure that if Spotify has, some say its payroll application also on Google Cloud, I'm very sure that they don't want to have the payroll application available to everybody, right? Suppose I want to find out what's the salary of the CEO of Spotify, etc. I don't want that to be available to me. So what can be done is, so a part of the so when we're talking about this concept of VPC, let me go back because somebody was asking about that concept once again. The idea is that your machines are having the option to connect to both internet and intranet. Okay, so this is the slide that I was referring to. So your virtual private network, you can configure in such a way that you can specify that, okay, this particular compute engine which I have purchased, it should be only having private, no public connection. There might be certain compute engines which might be only on the internet, need not be on the intranet at all. And then there can be a machine or a compute engine which is available across both. And you will have to obviously, make sure that you are taking care of the respective security on your own. Okay, so there's also this concept of shared responsibility. Okay, which is another typical cloud concept. So whenever you are purchasing any of these services from these vendors, okay, suppose I take a compute engine from Google. Okay, so now what Google will make sure is that when that compute engine is provisioned for me, they will give me this option of exposing it on the internet or keeping it within the intranet. Okay, now that is the responsibility of Google, that I will give you options to enable both. Now what is my responsibility as, say, if just take the example that I am an employee of Spotify. So when I am purchasing a compute engine from Google, Google has the responsibility to provide both options. Now it's my responsibility to make sure that I am configuring this compute engine in the correct way. If it is my public website which has to be accessible on the internet, I will make sure that it has the public connection enabled. But if it is, say, my payroll application has to be internal only, I will make sure that it is available only on the internet. Okay, so that's how you can keep your data safe. So that is where my responsibility comes in. So that is the concept of shared responsibility on any cloud providers, where you have the providers have the cloud providers have the responsibility to give you all the options that you might require. But the moment they have given the options, it's your responsibility to configure the services in such a way that you are not your data is kept secure, data privacy, data security, etc. concerns are taken care of. Okay, so how do you migrate data from your on-prem database to a cloud database? And similarly, you have applications which are dealing with you have to migrate your applications also from on-prem to cloud. So I'll also try and explain and answer your question by explaining another concept. When you're talking about cloudifying your enterprise, right? I'm just loosely using a term. I don't know if it is a valid term or not, but when you're look at moving stuff from on-prem to cloud, there are actually 2-3 different options that you have. The first option is what we call as lift and shift. Okay, so when you're talking about lift and shift, all you're doing is you're actually just moving your hardware or your application software, etc., from the on-prem server. So you might actually physically move the machine or something of the sort, or you can move the image, okay, of your local servers and get them set up on your cloud servers, or you can just do the same installation on a cloud compute engine. Okay, so that is something known as lift and shift. Okay, the other way to look at cloudifying your enterprise is to see if there is a chance to modernize your enterprise. Okay, so when you're talking about modernize, that is where the concept of, suppose, something like a cloud native infra comes up. So if you want to, so for example, if you have a monolithic application, okay, built 20, 30, 40 years ago, especially in IT companies like mine in TCS, we come across a lot of clients where based in the US, I was in a project working from Sweden, where there were applications as old as 40, 50 years old, which was still running perfectly fine. There was no, performance complaints or anything like that. But at the time, maintaining them was becoming a nightmare, because those kind of I'm even now. This is a technology Fox Pro or something, if I remember correctly. That was one of the technologies which was very hot in the 90s. But now I'm pretty sure none of this generation of people don't know this term called Fox Pro, Fox Base, etc. There were all these various applications. So if you want to maintain those and just do a lift and shift, it becomes a headache, because you will not find developers or experts who are knowledgeable in that area. Okay, so that is where the concept of modernization also comes in, where you don't want to do a lift and shift. What you want to do is you want to take a look at redesigning, re-architecting, refactoring your applications, so that you can, a monolithic application, can you make it into a microservices enabled application? Okay, an on-prem one, can you make it into a cloud native infra? Okay, so there are various options which you have to consider first. And then for each of these options, there are various services which either the vendor itself can be providing, either Google might be providing on its platform, or all these cloud vendors also have this concept of a marketplace. Okay, so in the marketplace, you're essentially allowing your partners and various other companies to come up with solutions for these kind of situations or problems. Say Microsoft Access database, and I want to migrate the data from that into, say, a Postgres database, or I have, say, a bunch of 5,000 documents in my on-prem and I want to migrate that into, say, a cloud storage option. Okay, so how do I do that? So either Google might provide its own services, or you can have these marketplace apps which can provide you these kind of migrations. Okay, so that's a typical example of how we can migrate. Now let's take a look at what are managed services. Okay, so managed services are essentially, so for example, we took a look at this compute engine, right, where you have a server which has CPU, RAM, storage, net, etc. Now this is a normal server. Okay, but this is something that you have to deal with it, right? So you have to deal with the various components inside it. A managed service is something which Google will take care of. Okay, so when you say, so for example, so this is there was few questions on different database types. Okay, so a Cloud SQL database. Okay, so Cloud SQL database is nothing but your same SQL Server kind of databases which are managed entirely by Google. Okay. So for example, tomorrow, if you, if any of you are fluent with say an Oracle database or a IBM DB2 database, etc., all these databases require, constant database administration kind of services. Okay. So you have to continuously keep installing patches to the databases, patches to the operating system on which these databases are there, etc. So instead of you having to manage it, when you go for, say a managed service like a Cloud SQL server, you can directly, uh, you know, um your Google take care of all the operating system and database patching, upgrading, etc., making sure that the storage is properly handled, etc. While all you have to worry about is take care of the data inside that database. Okay, so loading it, accessing it, using it, exporting it, etc. All that is your headache. So this is what is known as a managed service. So this is an example of what we call as pizza as a service. Okay, so if you just Google for this term, pizza as a service, a very famous term. So this is trying to explain the concept of on-prem, cloud, and then the various flavors of cloud. So we have something known as infrastructure as a service, platform as a service, and software as a service. Okay, so when we are talking about, if we take the example of pizza as a, okay, so when you're doing on-prem, you're talking about, making it at home. Okay, so you have to buy the ingredients, you have to buy the, the hardware that is required to process those ingredients, and then you have to also buy everything that is required to serve the ingredient. Okay, so when we are talking about infrastructure as a service, so this is like a take and bake kind of a option where you can go to a supermarket. I think even in India, Reliance Fresh or Big Bazaar, etc., they have these frozen pizzas. Okay, so you can buy those. So the ingredients and everything somebody else has taken care of. You need to have your oven or your um, electric, gas, etc. utilities to. Let me just put the pointer. The this portion of the the baking has been done for you, and you just have to take care of the oven and the the serving part. So when you're talking about infrastructure as a service, this is the basic thing where you are buying, say, a Google Compute. So Google Compute is an example of infrastructure as a service. So I am telling Google I need a machine with say 32 GB RAM, 500 GB hard disk, and Linux, say RHEL, Red Hat Enterprise Linux version 7.8 or something. So then they will give you the machine, and then on top of that, my applications, my everything else is my own headache. Okay, when you are talking about platform as a service, so that is where the example that we were taking of say a Cloud SQL database. So a Cloud SQL database is something where not just the underlying compute, but the database, the entire administration of the SQL database is something that Google is providing. All you have to do is take care of your own data. Okay, so the data is yours, and the cloud database is available to you as a managed service. Okay, so that's your example of a platform as a service or a managed service as we are talking about. And then finally, you have the software as a service. So typical example of software as a service is, the best individual example can be what we were talking about initially, say a Gmail or, Google Drive, etc. Okay. So you just have to go to mail.google.com, and you can start, sign up, and you can start sending, receiving emails, and start doing your work. Okay. You go to drive.google.com, you can immediately start, storing files, uploading files, sharing files, receiving files from other people, etc. So over there, in a software as a service scenario, the entire application itself is available to you. You don't have to worry about anything at all. You just have to, you can give the application on day one to your users. So a typical example would be, I don't know how many of you are familiar with applications like Salesforce.com, okay, or I think Closer Home. You have a lot of these ERP applications which are available on the internet. So you don't have to worry about the infrastructure. You don't have to worry about the database server, the application server, the integration server, etc. You don't have to worry about the application, building the application also. Everything is available for, all you have to do is sign up and start using it. Okay, so that's the the most convenient, and mapping to say, so that the pizza comes in. So the first is the take and bake, where you buy frozen pizza from a supermarket, and then you have to prepare it. The second is where you have the option like Swiggy and Zomato nowadays, where you purchase the hot pizza and it just arrives at your desk and you take it. And then finally, the dining out option is where the SaaS comes in, where you're talking about you can just go to a restaurant and eat. So that table and soda and everything is all, nothing has to be yours. All you have to do is just go and eat, right? So that's typically, I just wanted to bring this slide in to explain this concept of a managed services. Okay. So now when you put all of this together, that is where you will get this example of, so say, let's take a look at these, the physical infrastructure. Okay. So when you're talking about, this is where, I was talking about the initial concept of fault tolerance and all. So this is, I'm sure, probably not the most up-to-date picture of, Google Cloud, but this is a representative, scenario of where all is Google actually located. Okay, so I'm sure by Google is present in more places in India also. I think Hyderabad also they have a data center and stuff like that. But just take a look at this picture as a representation of the global outreach of these large platform providers. Okay, so right from Asia Pacific to Middle East Asia to Europe to the US, North as well as South America, etc. These these platforms are prevalent all over the place, and that is why, and then within these regions you also have various zones. So that is where the fault tolerance comes into the picture. So like, for example, in the India region, you will have zones such as West India, South India, East, etc., like that. So there are concepts of zones which give you this so regions and zones. So here's one region where you have US West, and then within that you will have zones West 1, West 1A, West 1B, West 1C, etc. So just data is, data applications, everything is well backed up across multiple places. So if I take the example of, say, a cyclone or a tornado or say an earthquake, etc., in these kind of eventualities, data will always be available to you. Okay, that's your typical concept of regions and zones. Then you can have your data spread across these regions and zones. So that's your typical concept of various services which are there from a Google Cloud concept point of view. Okay. Having said all of this, there's also one more slide which I wanted to share with all of you. So this is your typical various services. So across vendors, whenever you're talking about cloud, right? So these are your typical services which are available to you as options across, the various, so we talked about compute and storage and all those kind of options, right? So when you're talking about these various services, you will have these available to you across the three prominent, players that we have. So in the case of Google Cloud Platform, your virtual servers are nothing but VM instances or the Google compute engine that we took a look at. If you're looking at platform as a service, you have the Google App Engine. If you're looking at serverless computing, you have cloud functions. Dockers, you have Google Container Engine, Google Kubernetes Engine, etc. Your storage, so you have Google Cloud Storage. Archival is Google Cold Line. Then file storage is Google ZFS or Aware. Then if you have global content delivery, where I was talking about, serving your website in different countries locally. So that is where Google Cloud Content Delivery Network comes into the picture. So you can host your website. Say code is present in, say, India, and then your website replicas are available locally in, say, Europe, US, Japan, etc. so that when users are accessing the application from those countries, they are going directly to the main, the local replica of theirs, so that the speed is quicker. Okay, so that's your. And then what I wanted to mention out here using this slide is, so from these most prevalent application services, you will almost always have options all across these platforms. Okay, so that was in a brief, I wanted to capture the various options that you have on Google Cloud, and I wanted to close this particular section by mentioning the equivalent services or options which you have in the other cloud platforms.